This video is on lean management and is one of several videos on this topic. It's advisable that you check each of the videos, make your own notes, and do some reading in the area and pad out your notes so you have a good understanding of what's meant by this often talked about style of management. So let's start with this one. We're going to first of all talk about specify value, how to specify value and what is meant by value in this context. At the heart of lean, management, at the heart of lean is the concept of value. Another common definition of value is that it's the opposite of waste. So we start by contrasting two extremes. One is value and the other is waste. So we can define value in terms of the contribution it makes to the business and what is value. And we can also look ahead in the context of the opposite of waste. So a reduction in waste is the creation of value. Just the other way around. Waste is often classified into one of the following 7 categories. Now this is dealing with waste. It's often looked at in the context of one of these 7. So overproduction is waste because it's overproduction. It's production that's going nowhere. It's not been ordered by the customer. It's not leaving the premises. It's simply overproduction. It's a waste of effort, a waste of materials and effort. Inventory may be too large. Inventory itself may be a waste. In an ideal world, deliveries should be small quantities delivered frequently so that the deliveries and production are enmeshed. They are synchronized. They are linked so that in a sense the supplier is a part of the production process. The supplier is the first link. The supplier is part 1 of the production process. Part 2 will be the internal processing the material into its final format. But any inventory that's kept is wasting. It's wasting a resource. It's just sitting idle. Inventory means that raw materials or components have come into the business. They're held in a bin, in a storeroom. They're not doing anything. They're not contributing to the business. They are simply sitting there doing nothing. They're a waste. And that is the view of inventory in the lean system. Waiting is also a waste. Sometimes workers have to wait while the machine is being maintained, or if the machine breaks down, people have to wait, or perhaps the machines are not perfectly synchronized, so the output from one machine is not sufficient to keep the next machine running, or the output of one machine is too much for the next machine. So there's waiting in the system. People are waiting, or machines are waiting, and that's a waste. Any waiting around is a waste. The whole system should be, in a sense, perfectly tuned. Unnecessary transport is a waste. Sometimes raw materials have to be moved from one part of the factory to the other. This requires people, personnel and machines and so on to move it's a waste. The design of the factory should be such as to enable an efficient flow of production from start to finish with unnecessary transport cut out. It's a waste. There could also be unnecessary processing. Sometimes a machine does a particular process and then the product moves on to the next machine where the second process, another process is completed. Well, is there an opportunity to do both processes on the same machine? Or is it possible to get a machine that can complete both processes? Is it possible to introduce mechanization into this, computerization? Is it possible to get a machine to do the two processes so there's less handling of the of the component, less handling of the job. So the job stays on one machine and two processes are run off very efficiently because the material is actually on the machine. It doesn't have to be moved off, set up on the next one and processed on the next one. Is that possible? If it is, then unnecessary processing, unnecessary handling can be reduced. So look at the whole production system critically and see if there is unnecessary processing. Sometimes people undertake particular processes for no apparent reason, perhaps cosmetic. Somebody sits around cleaning the product at halfway through or something. Is that necessary? If it's not necessary, cut it out. And look at unnecessary human motions. Sometimes people have to walk between machines and pick up the items and move back to the other machine and set it up, or walk to the stores, or people just seem to walk round production systems. People may have to do many tasks which could otherwise have been automated, which could have been mechanized and processed by the machine, and perhaps processed more efficiently by the machine. So it's all the movement, the human movement, is it all necessary? Or is there a better way of designing the work process? And of course, defects are complete waste. Defects are very destructive in terms of the system and the business itself. Defects represent not just raw materials, which are now useless, but they also represent effort and work that's gone into processing the raw materials, which now proves to be defective. So it's quite a costly thing to happen. To have a set of defects is costly. It represents the raw materials, all the handling and all the processing that's gone on up to the point where it becomes a defect. So defects are costly. Now, those are 7 areas in which we can identify waste. Now, identify the value stream. Well, the value stream includes all activities, value added and non-value added. It includes all the activities from the creation, from raw materials to the final product, final delivery of the product, I should say, to the end consumer. So the value stream is the whole process. It starts with the delivery from the supplier, the whole process within the business of the creation of the product, until it's finally distributed and in the hands of the buyer at the other end. So the value system is the whole system. Activities within the value stream map are often broadly categorized as value added. So activities within the value stream map are often broadly categorized as value added. That each part of the system is adding value. We start with the raw materials, and then some value is added. The first process is added. Then it moves to the second process. More value is added. And it continues all the way along until dispatch. And value is added at every stage. There's also non-value added, but necessary. Sometimes within the system, forms have to be completed, or records have to be kept, or it's not adding value to the product, but it's necessary. It has to be done. If it's not done, the system may come to a halt, may come to a stop. So it's non-value added, but it is necessary. And of course, there's also non-value added and not necessary, which is wasteful. This is where people are waiting for raw materials, or waiting for components, or waiting for a machine to be fixed, or waiting for the lorry to distribute the items, or waiting for something. Non-value added and not necessary. It should have been solved. It should have been programmed in and dealt with during the design stage of the business. So we try to make value flow. That's the idea. The value should flow through the system. Having identified the value stream, the next step is to transform it from the traditional batch and wait approach to one where the flow is continuous. So we have two concepts here. One is the so-called batch and wait. We make the items, we batch them up, we produce the items, and then we put them into the stores, waiting to be sold. That's one approach. We have all the issues of trying to predict demand and all the issues of maintaining the stocks and checking stocks and inventories and so on. The other alternative is the flow is continuous. We wait for the orders to come in and we complete the orders in a very timely manner because the system is efficient. Right from start to finish, it's efficient. The order arrives from the customer, it's processed right from start to finish in a very efficient manner and dispatched. So the work is continuous. It's flowing through all the time, but it's flowing through according to the orders that are being received. It's not being produced in the hope of selling. It's not being batched up. Orders, work just going through, and at the end going into the stores and waiting, and people sitting around with their fingers crossed hoping they're going to make the sales. This is a more continuous approach. A key aspect to achieving such a smooth flow is to master schedule small lots of final products. Now, that's quite a clever way of doing it, to make small amounts. So you have a continuous flow, making small amounts, adding them perhaps to stock, not batching them up in big groups, and when the orders arrive, it's partially completed because the work has just been running through. And if the item is standardized and there's a good history of ordering and the management know that the product is still in demand, then small amounts which enable production to run smoothly is a good idea. So the system is running, but it's not running at a high level. It's running to capacity. It's just that the system itself is scaled to smaller amounts produced. So instead of producing 100 a day, the system is scaled down. The machines are not as big, if you like. The whole process is scaled down and they only produce 10 a day. But when the order arrives, they have met it. They've met the order and they've had continuous production, continuous flow of output. We can illustrate this by looking at a very simple example. Look at a fast food restaurant, a typical fast food restaurant, let's say. Let's just have a flow diagram to show what we mean here. So customers arrive at the restaurant. So the next thing is to decide, is it a drive-through? Can they just press a button in the car, sit in the car, press a button, order their meal and drive up and pick it up and drive off? Now if it is a drive-through, then they wait for service. They press the button and wait for someone to answer. May I take your order, please? Then they place the order. So the order is whatever they want. It may be that it's not drive-through, in which case they wait to order. They have to queue up perhaps and wait until they can place the order. They have to go into the restaurant and place the order. So they have to wait to order, and then when their waiting is over, they actually place the order. So there are two ways in which we can get to the order point. One is by drive-through and the other is not. Once the order has been placed, they pay for the order. Then the order is prepared. So they've paid for it. Now the business prepares the order. Now To do this, they may have partially completed products. They may have items on their menu partially completed. They just need the final phase. And these, if it's a popular restaurant, these items are coming through all the time. So it's a continuous flow. And the flow is regulated according to the time of day, the day of the week, and so on. And the history of the business tells the management what they need to produce. So there's continuous flow, and there's some waiting time on the part of the customers. They have to wait for their product, but it should be pretty fast and get the order, and that's it. So it's very similar to an engineering business. The engineering business, the orders for its products may arrive fairly regularly, or they may arrive once a month or once a week or whatever. In which case, the business is able to have continuous flow of production. It knows the orders, the chances are the orders are going to come in. But over the time scale between the orders being placed, so from one order to the next, they have continuous production. And the production is at a level which enables them just to complete the order when it arrives. So they're not producing for stock, they're producing in anticipation of the order. Of course, if the order doesn't materialize, they will have produced for nothing, and that's a waste. That's against the whole philosophy of what we're talking about here. But on the other hand, the business is scaled, so it's not perhaps such a disaster. The whole production system is scaled to the size of the orders that they receive. Okay, so that's another class on lean management. As I said at the outset, please look at the other classes, start putting the whole ideas together, what it is, what's meant by lean management, do some reading, and prepare your own notes. That's all I'm going to deal with in this class. We're going to leave it at that and say thank you for watching.